So, after understanding the meaning and concept of correlation and importance of correlation among the various sectors or field, let's start the next topic, kind of correlation. So, there are many types of correlation, basically positive and negative correlation, linear and non-linear correlation, simple, multiple and partial correlation. So, what is positive and negative correlation? So, as we have already discussed, that correlation is a used to study the relationship among the two or more variables. So, positive correlation is that when, as you can see in this, when two variables move in the same direction. Okay, that is positive correlation. What is negative correlation? Negative correlation is that when two variables move in opposite direction. Okay, when two variables are moving in same direction, that is positive correlation, and when two variables are moving in opposite direction, that is negative correlation. One is going towards the left and one is going towards the right, that is negative correlation. Now, linear and non-linear correlation. So when change in one variable tend to bear a constant ratio to the amount of change in other variable. Okay, that is linear correlation. When there is a change in one variable, the other variable, the change in other variable remains constant. Okay, that is linear. And non-linear correlation, when change in one variable does not bear a constant ratio to the amount of change in other related variable, that is non-linear correlation. Now the next one is simple, multiple and partial correlation. So simple correlation is when two variables are studied. Simple correlation is when two variables are studied. Okay, as in correlation, we have to identify or check the relationship among the two variables or more variables. There cannot be single variable. You cannot check correlation in one variable. You need two or more variables for finding the correlation. Multiple correlation. So when relationship among three or more than three variables is studied. Okay, three and more variables is studied is multiple correlation. Partial correlation, when relationship between two variables is examined, keeping other variable as constant variable. So in partial correlation, there are many variables. So when we check the relationship, we check the relationship between two variables and other variables remain constant. Okay, other variables remain constant. Okay, so this is how these are the types of correlation. Let's understand all these correlation in detail also, all the types of correlation. So first one is positive correlation. So what is positive correlation? When there are two variables, as you can see here, x and y, when there are two variables x and y and they are moving in the same direction. Okay, they are moving in the same direction. If x is moving like this, so y is also moving like this. Okay, so correlation, in this case, correlation is said to be positive correlation. It means basically if one variable is increasing, then the other as an average also increasing in the same direction. Okay, so when the variable is increasing, the other and average is also increasing. In one variable is decreasing, then the other variable, the average of other variable is also decreasing. So then the correlation is said to be positive correlation in this case. For example, let's take an example of height and weight. Okay, so the correlation between height and weight of a group of a person is a positive correlation. Okay, if height of a person is increasing, then the weight of that person is also increasing in the same proportion. Okay, if suppose an example x and y two variables, and we have to identify the relationship between these two variables, that there is a relationship between the variable is positive or negative, then we have to check in which direction the variable is moving. So as you can see in this example, variable x and y are given. So the variable x is increasing. Okay, so the variable of x is increasing with the ratio of 10. First is 20, 30, 40, 50 and 60. So the difference between the variables is number is 10. Okay, the difference is 10, and the other variable, which is the variable y, it is also increasing. First 120, 170, 220, 270 and 320. Okay, so this is also increasing in the same ratio. So when the variables, the you can say are moving in the same direction, then that is a positive correlation among the variables. Means one variable is increasing, then the other on an average also increasing in the same proportion to the other one. Okay, so in this example, both the variables are increasing in the same proportion. As you can see in this example, both the variables are decreasing. Okay, so they are decrease in the variable x and variable y, as it is decreasing by the difference of 10, 60, 50, 40, 30 and 20. Similarly, variable y, 500, 400, 300, 200 and 100. The difference is 100. Okay, so this show positive correlation among the variable. Okay, so as x is decreasing, then y is also decreasing in the same average. Okay, so this is the positive correlation. Now we will come to the next, that is negative correlation. Okay, so what is negative correlation? When the variables are moving in the opposite direction. When variables are moving in the opposite direction. If both the variables are moving in opposite direction, then the correlation is said to be negative correlation. So if mean of one variable is increasing but the other variable is decreasing, or if one variable is decreasing, other variable is increasing, then the correlation among the variable is negative correlation. Okay, for an example, the correlation between the price of the product and the demand of the product is negative correlated. Okay, price and demand are negatively correlated. As price increase, demand will decrease. If the price of one product is increases, then the demand for that particular product will be decreases. Okay. So this is how negative correlation work. Suppose you can see, suppose price of a product is 6. Okay, 6, and demand of that product, if price is 6, then demand is, let's assume 75. Okay, and if price is 5, demand increase by 100. Again, if prices increases, suppose it increases 6 to 5 and 5 to 4, then demand, suppose it increases by 180. So what you can see in this, the movement of both the variable is in opposite direction. If price is in decreasing, the demand is increasing. So this type of relationship is said to be the negative correlation. As we can also see in this example, rise in the value of one variable and fall in the other variable. So there are two variables x and y. If there is a rise in the variable x, as you can see in this example, 10, 20, 30, 40 and 50, the variable y will start falling. As variable x is increasing, variable y is decreasing. As you can see, 100, 90, 50, 60, 70 and 60. So the difference is similar, 10. Okay, as you can see. So this type of relation is said to be negative relationship or correlation among the variable. Similarly, if the value of one is increasing, rising in the value of one variable, uh, result to be the fall in the value of other variable. So as variable x is again decreasing, or you can say the value of variable y is increasing, 100, 200, 300, 400 and 500. This result to be decreasing in the value of x, as when the value is 100, when the value of variable x is 100, the value of x is 250. As the value of variable y is increased 100 to 200, the value of variable x is decreased from 250 to 200. Again, if when value of y is increased from 200 to 200 to 300, the value of variable y is decreased from 200 to 150. So similarly, it goes. And the process goes on. As value of variable y is increasing, the value of variable x is decreasing. Okay, so these type of variable is said to be negative variable. Okay, now next one, linear correlation. Okay, now linear and non-linear correlation. So what is linear correlation? So, if the amount of change in one variable bears a constant ratio of the amount of change in the other variable, so then correlation is said to be linear correlation. So, if such variables are plotted on a graph paper or on a graph, all the plotted points, so as when we, so in this case, when we plot all the variables on a graph, then they are come on a straight line. That is linear correlation. Okay, when we plot a graph, like as you can see, when we plot a graph, okay, so points would fall on a straight line, like these are the points which we get when we check the correlation. So they will fall, as you can see, in a straight line. Okay, that relationship is basically said to be the linear correlation. As there is a, you can see in this example, there is a raw material and finished product. So this is variable x and this is variable y. So when variable x is increasing 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. So product y is also going in the same direction, 2, 4, 6, 8, 10, 20. Okay, so they will all fall in a, you can say, straight line. Okay, they will fall, all the dots which we plot on the graph, they all will fall on a straight line. Okay, that relationship basically is called linear correlation. Okay, it represents a linear correlation among the variables. Now non-linear correlation. What is non-linear correlation? So basically, if the what is nonlinear correlation is that if the amount of change in one variable does not bear a constant ratio to the amount of change to the other variable, then that correlation is said to be nonlinear correlation. So, if such variable in non-linear correlation, variables are plotted on a graph, the point would fall on curve. Okay, so all the points which we draw on a graph for both the variables x and y, they will create, they will fall on a curve. Okay, and they are not in a straight line. So, for example, if we doubt the amount of advertisement expenditure, then sale volume would not necessarily be double. As you can see in this diagram, as just a minute. As we can see in this example, that advertisement X is 10, 20, 30, 40, 50 and 60. Okay, and the variable y is 2, 4, 6, 8, 12, 10 and 12. So when we draw uh, like points on the graph, then they will create a curve. Okay, they will not fall in a straight line, they will not fall on the straight line, they will fall on this curve. All the dots points we draw with the help of graph for checking the correlation among the variable, then they will create a curve, not a straight line. So these type of variables said to be non-linear correlation. When the amount of change in one variable does not bear a constant change in the amount of other variable. Okay, that is non-linear correlation among the variables. Now we will understand the simple partial and multiple correlation. Simple partial and multiple correlation. Now let's understand the concept of simple, partial and multiple. As we have already discussed, when in simple correlation, we study the relationship between or the correlation among the two variable. In partial correlation, we study the correlation between three or more variables. And in in multiple correlation we check the correlation between three or more variable, and in partial correlation we check the correlation among the two variables and other variable remain constant. So when only two variables are studied, that is said to be simple correlation. Okay, when one studied relationship between the marks which were secured by student and the attendance of the student in class, it is the problem of simple correlation. Okay, when we only study two correlation, when we check the relationship between the marks scored by the student and the attendance of student, then that type of problem is said to be simple correlation. Okay, if we talk about the partial correlation, we can also take one more example. For example, relationship between price and demand, as you can see in this slide. So when we study the relationship between only two variable like price and demand, then it is also said to be simply correlated. Okay, if we check the relationship between price and supply, then it is said to be simply correlated. Correlation, simple correlation. Now partial correlation, what is partial correlation? So in the case of partial correlation, one studies three or more variables but consider only two variables. Okay, in which in partial correlation basically two variables were studied and other variables remain constant. Two or more variables are studied and other remain constant. So more variable but consider by two variables to be influenced each other, and the effect of other influencing variable being constant in case of partial correlation. For example, when we check the relationship between the student marks, scored marks, and the attendance, the other variables influencing such an effect like teaching of a teacher, use of teacher aids, use of computer, smart board, and other method of teaching, these variables remain constant. So these type of correlation is said to be partial correlation, in which two or more variables are studied and other influencing variable remain constant. Next is partial correlation. So in partial correlation, when we study three or more variables, in the case of multiple correlation, we can say that if study covers the relationship between student marks and the attendance of student effectiveness of teachers, use of teaching aids, in this case of multiple correlation. Okay. So these are the types of correlation which we understand till now. Okay. Positive and negative correlation, linear, non-linear, simple, partial, and multiple correlation. And the degree of correlation. So there are many degree of correlation. So the important degrees of correlation are perfect correlation, zero correlation, and limited degree of correlation. So as coefficient of correlation, we can measure the degree or extent of the correlation between two variables. So on the basis of the coefficient of correlation, we can also determine whether the correlation is positive or negative, or also its degree or its extent. So basically correlation lie between +1 and -1. So this correlation is said to be perfect correlation when correlation lie between +1 and -1. Okay, so first of all, what is perfect correlation? If two variables change in the same direction and in the same proportion, so that correlation is said to be perfectly positive correlation. Okay, so according to Carl Pearson's coefficient of correlation, uh, uh, in the case of +1, basically he tells the case of +1 that correlation is need to be is +1. So Carl Pearson uh, coefficient of correlation is given by the Carl Pearson, who is an who give this formula of Carl Pearson coefficient of correlation. On the other hand, we can say that if the variable change in the opposite direction and in the same proportion, then the correlation is perfectly negative correlation, means -1. So if coefficient of correlation is -1, in practice we rarely came across these types of correlation. When we practically do the questions or we do the practical application of correlation, then it is very rare that the correlation is come -1. So that is perfect correlation when the correlation among the variable is +1 and -1. Okay. So, what is the absence of correlation means no correlation or zero correlation. In the absence of correlation, there is no correlation or zero correlation. If two series of variable have no relationship among them, or there is a change in one variable does not lead to any change in the other variable, then we can firmly say that there is no correlation among the two variables. In such case, coefficient of correlation will be 0. The coefficient of correlation will be 0 when there is no relationship among the two variables. With the change in one variable, other variable does not affect. Okay. If we talk about the limited degree of correlation, in limited degree of correlation, two variables are not perfectly correlated, or other is perfectly absence of correlated. When then we term the correlation as limited correlation when there is a not the correlation among the variables is not perfect, or there is a perfect absence of correlation among the variables. So basically, the correlation is said to be perfect. Uh, you can say that a correlation may be positive and negative or zero, but lie within the limit of ±1. Okay, so correlation may be positive, negative, or zero, but it lie within the limit of plus and minus 1. Okay, so we can say that, let me write here, R is equal to -1 and R, okay, plus 1. Okay, then plus and minus sign are used for positive linear correlation and the negative linear correlation. Okay. So this plus minus sign basically indicates the positive linear correlation and the negative correlation, but the value of R is denoted with correlation, coefficient of correlation. So it should be between plus minus 1. Okay, so these are the degree of correlation. So we can on the basis of this we can say that if x and y have a strong positive relation, suppose there are two variables, uh, just a second, if there are two variables x and y, if we have two variables x and y have a strong positive linear correlation, then the value of r, the value of r is close to plus 1. Suppose we are studying two variables x and y, there is a positive linear correlation between x and y. So the value of r is come close to plus 1. And R value of exactly plus 1 indicates a perfect positive correlation. Suppose you are calculating coefficient of correlation of two variables or more. Suppose you are calculating for variable x and y, and the value of R is equal to plus 1, exact plus 1. Okay, so then it show a perfect positive correlation. Okay, what it show? It show perfect positive correlation. Okay, and if it comes near 1, the value comes near 1, then it shows, suppose the value is 0.75. Okay, suppose a value is 0.75, then it is a positive correlation and it is said to be high degree of correlation. Okay, this is how it works. And next, let's understand when we are doing the analysis of correlation. So, if the value, if two variable, again we are studying two variable x and y. So, if x and y have a strong negative linear correlation, so the value of r is close to minus 1. Okay, if we are studying two variable x and y, when we calculate coefficient of correlation, the value of r will come close to minus 1. Suppose minus 0.75. Okay, like this. So an r value of exactly minus 1 basically indicates the high degree of negative correlation. A value will come exact minus 1. If the value of r came exact minus 1, then it shows a high degree of negative correlation. And if value of r will come plus 1, then it shows a high degree of positive correlation. Okay, so this is how the degree of correlation work when we calculate coefficient of correlation, which is denoted by r. So if there is no correlation between the variables, suppose we have taken two variables x and y and we are calculating the coefficient of correlation, we are calculating the value of r and it come close to 0. Then it shows that there is no relationship among the variable x and y. Okay, so now you understood the degree of correlation, that if the value is closer to close to plus 1, then it shows a positive linear correlation, and the value is close to minus 1, it shows a negative linear correlation among the variable, and value is close to 0, then there is weak linear correlation, or there is 0 or no correlation. If the value come exact plus 1 and minus 1, if value is exact plus 1, then there is a perfect positive correlation, and value is exact minus 1, then there is perfect negative correlation. And if value came to 0, then there is a no correlation between the variables. And if value is close to 0, then there is a weak linear correlation among the variables. So as you can also see in this table of degree of correlation, as I have discussed, that perfect correlation +1, that perfect positive correlation -1, perfect negative correlation. If we talk about the high degree of correlation, means it is near to 1. The value of positive correlation is near to +1 and the value of negative correlation is near to -1. This is the case of very high degree of correlation. Now, if we talk about the, we can say that if we have to check the moderate correlation, moderate degree of correlation among the variable, then it will lie between plus 0.252 plus 0.75 in case of positive correlation, and in case of negative correlation value lie between -0.25 to -0.75. And if there is a low degree of correlation, value of positive correlation is between 0 to plus 0.25, and in case of negative correlation value lie between 0 to -0.25. And there, if there is a no correlation or there is a zero correlation among the variable, then the value came 0. Okay, so these are the degree of correlation. Now, next topic is method of measuring of correlation. So, for measuring correlation among the variables, there are two methods: graphical method and algebraic method. We can measure correlation through graphical representation and through algebraic method also. Okay, if we are going for graphical methods, there are two methods: scatter diagram and graph method. This scatter diagram is most commonly used method, and it is very common and used by various researchers while doing the research. And second method is graphical method. When we do the algebraical calculation of correlation, so the methods are Karl Pearson coefficient of correlation, Spearman's rank coefficient of correlation, concurrent deviation method, and method of least square. So these are the algebraic method of calculating correlation, and scatter diagram, graph method are the method which are used for graphical method of correlation. So first of all, we will understand scatter diagram. So scatter diagram, there are the scatter diagram is categorized under these category: perfect positive correlation, perfect negative correlation, high degree of positive correlation, high degree of negative correlation, low degree of positive correlation, low degree of negative correlation, and no correlation. So basically, scatter diagram is also known as scatter plot, which are used for graphical investigating the possible relationship among the two variables without calculating any numerical value. So with the help of scattered plot and scattered diagram, we can easily identify the relationship among the variables, okay, without the mathematical calculation. So basically in this method, the value of two variables are plotted on a graph paper. So one take along the horizontal, which is x-axis, and other one will take the vertical, which is y-axis. So when we plot the dots on a graph, there is x-axis and y-axis for both the variables. For x-axis, and for plotting y for is y-axis. Then with the help of both the variables, by plotting data on x-axis and y-axis, we get dots, or you can say we got points on the graph which are generally scattered, and hence the same scattered plot. Okay, so as we can say that when we draw a graph for x-axis and y-axis, we plot points. Okay, the points are plotted on the basis of information given for x-axis, or you can say for both the variables x and y. With the help of the information, we draw dots or plot points on a graph. So the manner in which basically these points are scattered, it suggests the degree and the direction of correlation, which we have also discussed in the degree of correlation. Uh, Basically, this scattered diagram and scattered plot show the degree and the direction of correlation among the variables. So the degree of correlation is denoted by the R, in which we are calculating coefficient of correlation, and its direction is given by the sign of positive and negative correlation. Okay, so let's first understand the meaning. After that, we will understand it with the help of diagram also. Scattered plot. First, perfect positive correlation, which is also R is equal to plus 1, which we have already discussed in the degree of correlation. So, if all the points lie on a straight line, the correlation is perfectly positive correlation. Okay, and R is basically plus 1. As you can see in this diagram also, so this is perfectly positive correlation among the variables. So this is y-axis as, and it is x-axis. Okay, so we are plotted dot here. Okay, they are in straight line. So with the help of the information of both the variables, we have plotted dots in a straight line. So when all the dots came in a straight line, then it is said to be perfectly positive correlation among the variables. So the R value in this case is equal to plus 1. Okay, so this is basically, this is perfectly positive correlation. Now, perfect negative correlation. So, if all the points lie on a falling straight line, the correlation is said to be perfectly negative, and the value of R is equal to 0. Sorry, it is equal to minus 1. So, as in the perfectly positive correlation, what we have seen is that the points which are plotted on a graph are going up in a straight line, are going up in a straight line. But in perfectly negative correlation, the points are falling in a straight line. Okay, they are falling in a straight line. It means if variable x is increasing, the variable y is decreasing. Okay, so in this case, the graph is falling, and the value of basically R is equal to minus 1. And in perfect positive correlation, both the variables are increasing in the same direction. But in perfect negative correlation, both the variables are going in opposite direction. That's why the graph or the plotted dots in perfect negative correlation are falling. Next is high degree of positive correlation. So the degree of correlation basically. So in high degree of correlation, the degree of correlation is high when all the variables, or you can say all the points which are plotted, are falling under a narrow band and is said to be a positive. When these show the rising tendency from the lower left hand to the upper right hand corner. So basically in this, the value of R is very high. Similarly, in high degree of negative correlation, the degree of negative correlation is basically high when the points are plotted falling narrow band. Okay, so they are falling in narrow band and show the decline tendency from the upper left corner to the lower right hand corner. So in this high degree of positive correlation, the plots which we are plotting are in a rising tendency, and in high degree of negative correlation they are in basically in decline tendency. If we look at the example of this, if we draw a high degree of positive correlation, so then the dots are in basically in rising tendency. Okay, they are basically, when we draw a graph in a straight line, they will all are in rising tendency. The plots which are drawn on the graph, they all are in rising tendency, and they all fall near to the value or to the straight line. But in case of highly negative correlation, if we talk about the highly negative correlation, let me draw first. The dots will are in decline form. Are in decline form. All the dots which we plot, they will all lie near the straight line, but in decline form. Okay, in decline form. Okay, so this is how it works. Now, next one is low degree of positive correlation basically. Okay, so low degree of correlation, the correlation between the variable is said to be low, but points which are drawn on a scattered diagram are highly scattered over the graph, and the rising tendency from the lower left to the upper right corner. So they are also in rising tendency, and in low degree of negative correlation, there it show a low and negative correlation, and the dots we plot on a scattered graph show a falling tendency. Okay, so in case of low degree of positive correlation, value of R is equal to plus low, and value in case of low degree of correlation show R basically is equal to plus low. If we have to draw the graph. So we can also say that, as you can see in this example, the plots which are drawn on a graph, they are near the straight line, but not on a straight line. Okay, they are not in the falling tendency, they are in the moving tendency toward the upward side, and the dots are the dots which are lying, they are near the straight line. Similarly, in negative, limited, negative one, dots are in falling tendency, and they all are lying uh, near to the straight line but not in the straight line. So that is limited negative correlation. Okay, so in this the value is not 0, it is greater than 0 but less than 1. Similarly, in positive correlation, the value is greater than 1 but less than 1. Okay, and the last one is absence of correlation. And in the case of absence of correlation, when we plot dots on a graph, then it shows it not show a specific pattern, or you can say it did not show any kind of pattern. So the dots which are plotted on a graph all are scattered. Okay, all are scattered. They are very far from each other, and they did not create any specific pattern. They are not upwards, they are not downwards or in falling condition. So in this case, the correlation is absence and the value of R is 0. In this case, the value of R is 0, and the dots we plot on a graph are not in any specific pattern. Okay, so that is said to be absence of correlation. You can say zero correlation or no correlation among the variables. Okay, so this is the scatter diagram.